Hey my friends, I Abhinav Negi welcome you all on BYJU'S Exam Prep Gate NESC YouTube channel. Everybody, a very warm welcome to all of you guys. I hope that I'm audible and visible. Whatever I look like, that is visible. I don't. Okay, Happy New Year, guys. A very Happy New Year to all of you. Yeah, it's sound is good in my phone, so I hope that it's good in your as well. Everybody, a warm welcome. So why we are here, guys? As we told you yesterday, guys, we are starting from today, that is 3rd January 10:30 a.m. the SOM marathon, and not only SOM marathon, the Maha Marathon of each and every subject, to boost up your performance, to scale up your performance, to increase your marks in the last 1 month, guys. I hope everybody is ready for this. And guys, what we are doing here, each and every day we are teaching you subjects. Like today it is SOM. Okay, then evening Joshi sir will be taking FM. In evening Joshi sir will be taking FM, guys. Okay, so this is SOM 1 and FM 1 today. Okay, so half of the SOM, nearly half of the SOM and nearly half of the FM done will be done today. Today this is at right now, and this is at 5 p.m. Okay, then after this, tomorrow again SOM 2 FM 2 will be like this, will be there, and carry on with each and every subject. A very good morning to all of you guys. I hope everybody is fine. Okay, so each and every subject will be done here, guys. What we'll be doing, we'll be doing the complete revision. Okay, revising the complete concepts, all formulas, all chapters, also the numericals that are very important at the last time. Guys, this about me, most of you already know me. Just let me again tell you about myself. My name is Abhinav Negi, having 9+ years of teaching experience. Done my MTech from IIT Delhi in Geotechnical Engineering. Got All India rank 164 in 2012. You have to score a better rank than this, guys. Mentored more than 20,000 students in offline for more than 8,000 hours. These are my subjects. Right now we are doing strength of materials. I always tell you same thing, yaar. I always tell you same thing, whether I'm 164 rank or whether I'm 1,64,000 rank. Whether I taught 8,000 hours or I teach 8 hours, that doesn't matter. What I'm telling you here, you're getting it or not, that is more important. Guys, a humble request from my side. Everybody, guys, please share the session so that more and more commandos can join in and let us have a blast here. This is my Telegram. Whatever I will be teaching you here, guys, whatever I'll be teaching you here, each and every PDF with my ink. Ink means whatever I'm solving the question, whatever I'll be writing, whatever I'll be writing like this dot, everything will be coming to you. So each and everything will be coming to you in my Telegram, that is Civil by Abhinav sir. Most of you already have joined. Those who have not joined, let me sharing the link for the Telegram. This is my Telegram where, guys, each and every PDF of my class will be available. Also the link, also the here is the complete schedule also. Okay, so there you can join me if you have not joined till now. These are faculties that are teaching you guys continuously in app or in YouTube. Okay, so okay, my photo is also there. Then guys, this will be the Maha Marathon. As I already told you, complete revision of all subjects starting from 3rd of Jan. Okay, and every teacher will be here, guys. Like just in few minutes, Joshi sir will be here. Right now I'm not in my office, I'm in my home, and within the few minutes, guys, Joshi sir will also be arriving. Okay, now guys, for all of you, one more surprise to all of you guys, that with MSQ session, okay, we will be there with me and Chandan sir and telling you about all the inside stories of the 3 different types of questions: MCQ versus MSQ versus NAT. Okay, where you can score more, which thing you have to, which battle you have to win, like this. The battle of MCQ, how to win. The battle of MSQ, how to win. The battle of NAT, how to conquer. That everything will be telling you today at 9 p.m. on Hindi channel, guys. Okay, that session will be today on 9 p.m. on Hindi channel. Okay, then guys, yes, 5 p.m. today, Joshi sir will be coming. Okay, he is taking the classes of FM1, SOM 1 FM1 today, SOM 1 FM1 today, and then SOM 2 FM2 tomorrow. Okay, SOM 1 FM1 today, SOM 2 FM2 tomorrow, and guys, each and every subject will be done here, or with all the faculties will be coming and teaching you the subjects. Okay, so these are the various things that we'll be studying. Let me just tell you one by one, everybody. This is the first chapter. Here we'll be telling stress and curves, stress and metrics, properties of material, thermal stresses, elastic constants, e.g. mu k, Poisson ratio, impact loading. Then SFD BMD of course, significance and numericals. Bending stresses and shear stresses formula, moment ratios of beam, flexural formula, shear stress variation for triangular eye and rectangular sections. Then transformation stress means that principal stress chapter, that Mohr circle. So analytical method, graphical method, Mohr circle for strain, strain then torsion will be studying. Okay, shear center, spring column, then pressure vessels, thin and thick cell. But of course, guys, this will be done in two methods. Okay, this will be done in two sessions. Today, one, most probably, guys, will be doing this first chapter, second chapter, and third chapter today. Okay, this is more than half of the SOM. This first, second, and you can take it third and fourth, bending stress and shear stress differently. So these things will be covering today, and that will be more than half of the SOM. Okay, so how's the Josh commandos, each and everybody? Please let me know. Please let me know, guys. How is the Josh? Good morning, Kushagra. Okay, around 7 January, guys, might be 1 or 2 day delay, maybe also there. Okay, so of course, if you have filled the form and there is no objection in that, of course, the admit card you will be getting. That is not much, don't take much load about that, huh? Don't take much load about the admit card. Anyhow, you will be getting this. Just say, come on, guys, you are not, just let me know how is the Josh. Nobody is telling it, or everybody is having low Josh in New Year. Everybody is having low Josh. Just tell me, guys, how is the Josh? Okay, hi. Okay, guys, these I will be giving you the PDF, guys, in my Telegram, Civil by Abhinav sir. Okay, how much time this session takes? Around 3 hours. 3 hours SOM part 1. Then Joshi sir will be coming in evening. In between, from 1:30 to 5 p.m. it will be your free time. You can take your lunch. You can do whatever you rest if you want. Okay. Baki subjects complete. Every day there will be a subject. Shubham, every day. 3rd, 4th, 5th, 6th, 7th, every day subject will be there. Okay, so let me tell you one thing. Let me do one thing. When Joshi sir is coming now, then I'll be pasting the complete schedule photo on his PPT. You can take pictures from there, or just after the session, I'll telling the complete in my this also. Telegram. Complete schedule in my Telegram. This is the correct sequence of studying SOM. If you are very new, to the SOM, if you are studying SOM first time, if a second year student is watching this session, guys, this is the correct sequence of studying the SOM. And guys, we will be doing this in part 1 today. Okay, and this is, let me tell you, this is more than half of the syllabus. This is more than half of the syllabus, and all these we will be doing tomorrow. That will be in part 2. Tomorrow 10 AM. Okay, Anand Sharma, everybody welcome. Himanshu. Okay. Sir, abhi ek bhi full test nahi diya. So guys, one thing I want to tell you, everybody, very important information. That's how many tests I have to give. Many questions are coming to me in my mail or my Telegram. Sir, how many questions I have to give? How many tests I have to give? Let me tell you the answer. Guys, if you have not started giving the test till now, you have to only give full length test, not the subject test. Another thing, how many tests, sir? Guys, if you are giving the test for analyzing your mistakes and improving those concepts which you have done mistake, let me tell you, if you are giving the test for whatever wrong you will be doing in the text, that you will be again studying that concept, again grasping that concept, or some other question you don't know at all, then those concepts you will be studying. If you are giving for that purpose, the number of tests should be at least 15 or 20, at least. If you are giving for the purpose, whatever you will do mistake there, whatever you will not knowing there, that you will be again studying, then in that case 15 to 20. If you are giving the test only for time management, you will be not studying those questions, those concepts that you have done mistake there. You will be doing your own revision irrespective of that test series. In that case, at least 5-6 tests you can do if you are only doing the time management. Okay, let's move further. The book for the SOM is Gareth Himshonke, guys. Okay, so let's start the first chapter, stress and strain. Everybody please like and share so that more and more commandos can join in. Everybody. Shall we start? Shall we start, guys? Everybody? Shall we start? Okay. Guys, first of all, sir, what is SOM? What is the subject SOM, sir? Okay, guys, after every chapter I will be doing the question as well. Let me tell you what is the today's task. Today's task, you have to be with me if you really want to grasp this series. What we'll be doing today? Task is this, na? Today task is this, na? So whenever I'll be completing this chapter, after completion I'll be taking 7 to 8 numericals also, and those numericals 99% will be new. Those who are following me from many years, many months, might be in app or YouTube, 90 to 95% questions will be new. Okay, yes, after Anjali, after every my class from last 2 years, after every my class, within 2 minutes I am putting PDF in my Telegram, still by Abhinav sir. Okay, after completing this chapter we'll be doing numericals. Okay, this will be a very, very big chapter. Then this will be small. Then we'll again doing numericals here also today. Then we'll be studying this numericals. Then we'll be studying this, and we'll be doing numericals here. Let me tell you one more thing. Okay, let us try to do this also today. Let us try to do principal stresses also today if time permits. Otherwise we'll be doing it tomorrow. Numericals. Guys, those numericals 90% will be new, that I have not ever taken in any of my previous classes. But guys, again one thing, many students are thinking now that if sir will teach us, that will be enough, we'll give the exam. Guys, see, this is a GATE exam. Around 1,30,000 people will be fighting for the rank. 1,30,000 in the GATE exam. And out of this 1,30,000, I never ever believe that the competition is 1,30,000. No. Out of this 1,30,000 guys, seriously preparing, okay, are only student guys, those will be around 25,000. What does seriously studying students means? Seriously means that those who have covered more than 70% of the syllabus, 70. Okay, if a student has only completed 40% of the syllabus, I am not considering him serious. Serious means those who have covered more than 70% of the syllabus, 25,000. And guys, in those 25,000, those who will be covering the syllabus, out of this, guys, you have to get a good rank. The serious competition will be 25,000, even sometimes lesser. Okay, so that will be your competition, guys, everybody. Now, moving forward, let us come to the basic of now SOM, from where the subject originates. कहाँ से आया है subject, कहाँ से आते हैं लोग, like in Johnny LLB dialogue is there, na? Okay. Where is my session? Okay. Okay, let's start. Okay, please have a bottle with you, copy and rough pen. Okay. Please don't note those points, those who are already here. Some people will be writing this also. Guys, I'll be giving you in Telegram. Okay, and please don't note those points also that I will write here. Whatever I write, please don't note that as well, because I am giving you Telegram. If some point that I speak and you find it very interesting, or somehow I am not able to write this in this PPT, only that point should be noted. Please bring your copy, pen, calculator, water bottle with you. Close the doors. Say to your parents or to your friends, wherever you are living, in your home, PG or guest house or hostel, that now for next 3 hours don't disturb. If you have a Wi-Fi connection, put your phone on the flight mode and make your Wi-Fi on. If you're watching on mobile net, of course, then in that case you can't make your phone off. Okay, let's start. Yes, let's start. Okay, so from where the subject SOM comes, guys, any body, suppose this is a body, and in this body if I apply a force like this, P1 force, okay, if I apply a force like P2 force like this, and if I apply a force P3 like this, okay, and the body has 2 points, suppose A and B here, A and B, and whatever the number of forces I am applying, not 3, might be 10, might be 20, whatever the number of forces I am applying, whatever be their magnitude, whatever be their direction, if the position of A and B is not changing, if the position of AB is not changing, then that is called as rigid body. Then that is called as rigid body. If whatever be the number of forces, not 3, suppose 15 forces I am applying, 105 forces I am applying, okay, and after the application of those forces in any magnitude, in any direction, if the position of A and B is not changing, that is called rigid body. In your 11th class, Monimita, actually spring is not in the syllabus. They have not mentioned the word spring, but sometimes they ask the question. Okay, now guys, see, whatever the number of forces, if the position of A and B is not changing, that is as it is, that is a rigid body. Whatever you have studied in 11th class, Newton's law of motion, gravitation, S is equal to ut plus half at square, rotational motion, gravitational motion, every physics, that 11th class physics, that blue HC Verma, okay, everything that is rigid body, consider the body as rigid. Engineering mechanics, you consider the body as rigid. In real life, no body is rigid. Sir, iron is rigid, sir. Sir, iron is rigid. Guys, come on, guys. Guys, what if you apply the force, iron will, the dimensions of iron will be changed. That little change is not visible by naked eyes. That little change might be 0.000000001 into 10 to the power minus 5 meter or micrometer. Okay, so nobody in this world is rigid. Everybody is deformable physics. Deformable means when there is, guys, the position of A and B changes. Either the body shape will be changing, dimensions, it will be, A and B will become closer or move farther, okay, or the orientation is changed. That is deformable physics. And first time a student studies deformable physics when he comes to strength of materials. Okay, great. See this, like this, so whatever, this chappal, okay, this compressing, this is a deformable physics. Everything is a deformable. Guys, one more thing, many students are thinking that a rigid body can't move. No, when I said it can't move, rigid body can move like this, rigid body can move like this, rigid body can move like this, but dimensions will not be changed. If here the length is 7 centimeter, here also the length is 7 centimeter. If here the width is 2 centimeter, here also the width will be 2 centimeter. Rigid body can change. Rigid body can change its position. A body can go from here to here. Okay, but dimensions, diameter, everything will be same. Okay, and rigid body is a pure assumption because no body is actually rigid body. Now, what is stress, sir? Guys, there are two types of stress: normal stress and shear stress. Okay, many times I have told you, everybody, this is P body, this is P force. Okay, this is P force I am applying. Let me take with black color. This is P force that I am applying. Okay, sir. Then reaction will be P. Okay, sir. This is the external force. Okay, sir. Then after I cutting the body from here, this is 1, this is 2. Many people know already this. Let me just tell you very fast so the time is not wasted. This is 1, this is 2. Okay, in one body, the external force but that I am applying, that machine is applying. Externally, I am applying it. I am applying the force. This is external force. This is external force. This is external force. Suppose somebody broke my heart, it's paining, that is internal force. Okay, now see, this is P force, this is external force, means somebody is applying or support reaction is coming. Okay, so guys, whole body is in equilibrium. Okay, sir, this body is in equilibrium. Okay, sir, so small body has to be in equilibrium. If this whole body is in equilibrium, so small body has to be in equilibrium. So making this equilibrium, a P force is coming like this. Yeah, now it is in equilibrium. See, this whole body is in equilibrium, small part is also in equilibrium. Guys, if I am in equilibrium, my nose is also in equilibrium. My nose is not going to office, not office. It is right now, I am in my home, so my nose is also in my home. So this P force is going upward, so for balancing, P force is going downward. Okay, sir, got it, sir. So stress is internal force by area, this P by A. Okay, stress is not external force by area. Stress is not external force by area. No, not at all. Internal force by area. Okay, sir, got it, sir. What is internal force? So external force that you are applying or machine is applying or support reaction, that is external force. What is internal force? Internal force is that is obtained after cutting the section. See, here no force is applying. Here no force is there. After cutting the section to balancing it, internal force is coming. Actually, no force is here. And internal force is always equal in magnitude and opposite in direction. P, equal in magnitude, opposite. One is upward, one is downward. See, when you join the two body, when you join the two body, so this P and P cancel out, nothing will be left. Nothing will be left. When you join the two body 1 and 2, this P and P cancel, nothing will be left. Everybody got it? Please make a heart sign. Yeah, come on. Everybody, Guna, Monimita, Anjali, Sakti, got it? Enjoying the guys, enjoying the marathon, everybody? Anjali, Karan, Indra, Varisha, Rizwan. How are you, Varisha? From Aligarh. Anand Sharma, Himanshu Gupta, Akins, Harshita, everybody else. Getting or not? Okay. Sir, what is shear? Normal stress is that is internal force is perpendicular. And shear stress is that is tangential. This is normal, this is tangential. Sir, where tangential will be coming, sir? Where tangential will be coming? Let me show you. Suppose this is a beam. See above your head, there are many beams now. One is in my, two, okay, and third is here. Okay, three beams here. Now, if this is the beam and supported over column, this is my beam. Okay, this is my beam. Abhinav sir's beam. Abhinav's home. And this is beam. Abhinav homes means beam. And here is column. Making a simple case, actually the beam is not that simple as you are seeing. And I am living in 9th floor. Oh, okay. Vivek. I'm not teaching. Vivek. Not enjoying? You can go. Okay. So Joshi sir is also here. Okay. So as I told you earlier, I showed you the pic also. Joshi sir will be coming at 5 p.m. Very soon he will be coming in my home. Joshi sir, at what time you are reaching here? Please let me know in the comment section. I have not seen your comment. Kahan gaye Joshi sir? Oh yeah, Joshi sir is also here. Joshi sir, at what time you are reaching? Kahan pahunch gaye? Where you have reached now? And put a screenshot. Okay. Now, see, this is my 9th floor. This is 9th floor and 10th floor. Suppose the load is coming, not UDL, but assuming it to be UDL. Suppose that person is having load applying 2 Newton per meter. Suppose this is 3 meter. So 2 into 3, 6 meter total load. So here 3 and 3. Okay. Let us make a more simpler case. Beam, assuming no point load like this. Okay, let it be 10, let it be 3, let it be 7. Okay. Now if I cut a section from here, see, take this as one body, take as this two body. So one body is like this, two body is like this. Okay, here is the 3 force acting, here is the 7 force acting, here is the 10 force acting. Now only considering the force equilibrium. Okay, Joshi sir has called. Okay, कहीं गेट पे पहुंच गए, गेट में तो नहीं हो रहा है. Okay, see, if this is the 3 force, I'm only considering force equilibrium, not moment equilibrium. So making it balance, 3 will be coming downward. Got it? Similarly, if 7 is here, 10 is here and 7, so 3 will be coming upward for balancing. Hello? हाँ. वो डाल देना screenshot. So this 3 is upward, so 3 is downward for balancing. And here 10 is downward, 7 is upward, so 3 is upward for balancing. So this 3 on this section is shear. 3 shear, tangential force. So tangential force upon area is shear stress. Okay, now one question, everybody, please reply. Let us see who can reply fast. This is suppose Joshi sir suitcase. And he is on railway station. This is platform. This is Joshi sir's school suitcase. And here, suppose Joshi sir is sitting over it. Platform is too much crowded, no seat he is getting. And Joshi sir of 80 kg is sitting on here in the suitcase. Let me know that what are the stresses coming on this soft delicate suitcase? Everybody, please let me know. What are the stresses coming? Is it normal? Is it shear? Is it zero stress? Ground reaction will be again 80 kg for balancing because suitcase will be in equilibrium. Okay, Rupesh, everybody, good morning. Please let me know. Okay, guys, Aman is there. Okay. Okay, man, Nitish, Lavanya, Sarang, Alok, Himanshu, acha, Sarthak, Karan, Kalidasan, guys, I'll 100%. 100%. Diksha, you also? Diksha, you also? Normal? Himanshu, Aman, I got your answers. Come on, Mohammed, Alok, Guna, my God, you will give me a heart attack, yaar. Oh, good, Kushagra. You will give me a heart attack. Good, Varsha. Only 5 people. Varsha, Himanshu, and couple of more. Aman and... You will give me a heart attack here. In online, teacher will go die. Those who are coming to my classes in YouTube or app, many times I said you. Normal says every 99% are wrong. Good, Jyoti. Guys, that depends on plane. If I cut this plane, suppose this XX. On this XX plane, guys, yes, this force is normal. On XX plane, sigma xx is coming, but there is no tangential component. On XX only normal force is coming, no tangential component. But as soon as I take a YY plane, in this YY plane, come on, yeah, you will give me a heart attack. This 80 kg is like this. So this has 2 components. One is like this. One is like this. This is suppose alpha. This is suppose beta. So stress on YY plane, normal stress on YY plane is alpha upon area of YY. And shear stress on YY plane is equal to beta upon area of YY. So sigma is also coming, shear is also coming. That depends on plane, yaar. Come on, yaar. Come on. मार दोगे भाई तुम टीचर को किसी दिन ऑनलाइन हार्ट अटैक, फिर आ जाएंगे इस पे 15 मिलियन व्यू. Okay, oh my God. Equality of shear stress. So guys, see, if I cut a body na, and I suppose say this shear is tau, shear stress. If this is a very small point on a beam, then 100%, how much should be this? This should be tau. 100%. Guys, if this is not tau, if one of them is greater, suppose this is greater, so body will move like this, na? I'm studying equilibrium body, beam, column, everything is equilibrium that you study. Okay? And suppose here is tau like this. Then 100% here should be tau, guys. It should be in equilibrium, na? Body is in equilibrium, na, guys? Come on, getting or not? Getting or not? Getting or not? Please let me know. Guys, can you tell me one thing? Many times question has been asked, not only in GATE but other exams as well. Not only in GATE but other exams as well. That 2 times it has been asked in MPPSC and couple of times it is asked in Andhra Pradesh APPSC. Okay, one time also in last 5 years I am talking, might be more. In last one time in Karnataka also. My question is why is this? Why I'm saying why the opposite stresses are equal? Please let me know why the opposite stresses are equal. Why the opposite stresses are equal? Please. Opposite phase stress are equal due to which equilibrium? Opposite phase are equal due to which equilibrium? Please. Please, everybody on the comment box. And why adjacent phase? Why adjacent phase are equal? Everybody. Opposite are equal due to force equilibrium. Opposite faces are equal due to force equilibrium. And adjacent are equal due to moment equilibrium. Let me make you feel now. Everybody, please see. Good, good, good. See, if this tau opposite, black, 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 black. If one of this, suppose this tau is bigger, so body will move right side. We study equilibrium bodies. Okay, this is are equal to force equilibrium. If this tau is bigger, this red tau, and this is smaller, so body will move upward. If this tau is bigger and this tau is smaller, the body will move downward. So opposite are equal to force equilibrium. And suppose I consider a movement about this point, blue point, blue. See, both are passing from here, so no movement. If this tau is black is greater than this red one, so black about this is clockwise and red about this is anti-clockwise, assuming this to be a square element, although that validation is for every body. Suppose this black is greater, this is clockwise, making it clockwise about this blue point, and red is anti-clockwise. So this will move clockwise if black is greater. If red is greater, it will be anti-clockwise. So adjacent are equal due to movement equilibrium. Many times this question has been asked. And opposite are due to force equilibrium. Okay, great. Now guys, everybody, let me tell you what is this stress in 2D, 3D. Let me tell you. Let us play a game, everybody. And guys, many people are watching mine around 150, only 114 likes. Guys, come on yaar. I will be taking soil and I guess hydrology. Okay, guys, like and share yaar. Many people are watching but only few likes. Come on. Okay, now please, here, see, let us play a game. I will ask you something, you have to name it. Suppose this is x direction. Okay, sir. Suppose this is y direction. Okay, sir. X is from your mobile or your screen, that is going right hand side. Y is that is going upward. And that is z. Sir, what is z? X we understood, sir. Z is that is coming directly to your forehead. That is z axis. So this is x, y, and z is directly coming out of your screen to your head. Now, suppose this is a body like this. Many questions are asked from here in the matrix forms, and questions I'll tell you here in the matrix form. Everybody, guys, can you please name what is this face? What is this face? What is the name of 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 this face? This. What is the name of this face? What is the name of this face? Guys, this face is X face. How, sir? Guys, any face name will be where the perpendicular is going, outward direction perpendicular. So outward, not inward, not inside the body, outward. Outward is going in X direction. So that is X face. No. Outward is going in X direction. That is X face. Nitish is saying XY. Vivek is saying XY. They are going into maths, coordinate geometry. This is Som. PDF I'll give in my telegram, sale by Abhinav sir. This is Som. This is my telegram link. This is Som, guys. Those who are saying XY, they are going in coordinate system. So this is X face. Okay, sir. Got it, sir. Now this face, this red face. Guys, outward normal, going outward, not inward, not inside the body, outward. Outward is going in Y direction. So this is Y face. Okay, sir. Got it, sir. Now, similarly, what is this face? What is this face? I will tell you very interesting things here. What is this face? outward normal is going in Z direction, so this is Z phase. Okay, okay, great. Okay, guys, now what is the name of the base where it is resting? What is the name of this base? What is the name of this base? What is the name of the base phase? This base. Come on, Raghu, yaar, come on, Raghu. Very close. Come on. Guys, what is the name of base? Come on, yaar. This base, where it is resting. Where it is resting. Come on. No, yeah, yes, Raghu good. Mokshin, Kalidasan, good. Yeah, Nitish. Yeah, Jyoti, good. Just one. Aman Devikar, very good. This minus y, because here outward normal is going in minus y direction. This plus y, this minus y. Similarly, this phase is minus x, because it is going in minus x direction. Okay, everybody got it. This phase is minus x, because, okay, and similarly the back phase, this one back is minus z. Now see, guys, in this phase, many things will be cleared. In this phase, what is this purple? What is this stress? Sigma or tau? What is this stress? Very interesting here. What is this arrow? It is sigma on this x phase, or it is shear? Sigma. Yeah, come on, it is normal na to x phase. Normal na to x phase. It is normal na yaar. Come on. It is normal to x phase na yaar. Normal na yaar. Come on, chaps. Sigma. Then the name of the phase, x phase. Then the direction, tui. This is x direction. Simple. Now similarly on this purple phase, what is this? Normal or shear? Shear, tangential. Come on, yes, everybody is correct. This name is tau. On which phase? First is phase. First word is phase. And second word is direction. On x phase, on which direction? Y direction. Simple. Everybody, what is the name of this? Tau. On which phase? X phase. In which direction? Z direction. Understood. Everybody now champion. Guys, this is normal or shear? On Y plane, this is normal or shear? Everybody, come on, Mansoor, Jyoti, Vasu, how are you? Everybody, please. What is this sigma or tau? This is sigma. Perpendicular to this red body. The first word is phase. On which phase? Y phase. Second word is direction. In which direction? Y. Understood, sir? This on red phase, this is shear. Where I write, this is shear. On which phase? Y phase. On which direction? X direction. Now this. On which shear? On which phase? Y phase. On which direction? Z direction. Understood, sir? Now I am coming on this green phase. This on green phase is normal. In which first word is phase? Z phase. In which direction? Z. This, sir, shear on green phase. On which phase? Z phase. On which direction? Y. Sir, this one, sir, this shear. On which phase? Z. On which direction? X. This on X direction. Everybody, please put a heart sign. Have you got all 9 elements? Everybody, please put a heart sign. Have you got all 9 elements? Put a heart sign. Those who got it, guys. Come on. So total, if anybody asks, how many elements will have? Sigma xx, tau xy, tau xz. Sir, you are not showing sigma xx here on this negative x phase. That will be there, na, equal. That will be there equal. That is only equilibrium body we are studying in SOM. So you, okay. Sigma xx, this 3. Then sigma yy, tau yz, tau yx, this is again 3, 6. Okay, getting students or not? Yes, they are getting. Sigma zz, tau zx, tau zy. Guys, if somebody asks you, please, everybody, GATE has asked this question. Now the question is there. Now GATE has asked the question. Everybody, please. How many total number of elements are there? Gate has asked this. How many distinct elements are there? What is the total number of elements and what is the distinct elements? Come on guys, reply. Total number of elements and distinct. Total number of elements and distinct. Please reply. Soon we'll be going to the questions as well of the first chapter. Everybody, come on. Yes, great. So total number of elements are 9, 3, 3, 3, 9 and distinct are 6. Why distinct are 6 guys? Because you all are champion. We just studied that adjacent phase stresses are equal. Good. Everybody is champion here. So I think whole competition is lying here. Whole competition of the gate is lying here in this channel. And again guys, I am saying you, very important announcement. There is no MSQ book available. There is no MSQ book available. On Hindi channel, we are coming with the MSQ series for every branch. Okay, Hindi channel. Again, I am telling you, Hindi channel. And today 9 PM we are coming you to announce everything about that. Okay, see how many slides are there? More than 182. But that is part 1 and part 2 both. Not of today. I'll share you the PDF. Okay, let's come here. Total number of elements are 9 but distinct are 6. Sir, how distinct 6? Come on here. Tau xy and tau y. No. Tau xy and tau xy and tau y, xy and yx are same. Adjacent phase. If tau xy is more than tau yx, it will topple to this side. And soon we study equilibrium body, not toppling. If tau yx is more, it will topple this side. So both are same. Adjacent phase due to movement equilibrium. Similarly, tau xz and tau zx are same. Okay. Similarly, tau yz and tau zy are same. So distinct are 1, 2, 3. Either of these, only one is required. 4. Either of this, one is required because other is same. Either of this, only one is required. So total there are 6. Okay. Now all these elements in SOM, they are represented in matrix form, that is called tensor. Stress tensor. All these are represented like this. Everybody, sigma xx, tau xy, tau xz, tau yx, sigma yy, tau yz, tau zx, tau zy, sigma zz. Okay. So these are on of the x faces, sigma xx, tau xy, tau xz. The second row is of y and third row is of green one. Okay. Now guys, this is symmetrical about the principal diagonal. This is diagonal and it is symmetric about this. Please check it is symmetric or not. See, tau xy and yx are same. See, tau xy, this is symmetric. They are same. Similarly, my friends, tau xz and zx are same. Tau xz and tau zx are same. Okay. Similarly, tau zy and yz are same. So it is symmetric about the principal diagonal. Got it? Shubham, you got it now? How distinct 6? Okay. So this is symmetric about the principal diagonal. So if somebody asks you why it is symmetrical, the answer will be movement equilibrium. This adjacent phase are equal due to movement equilibrium. Okay. Now what is the order of tensor? Guys, see. 3 you have to write x. X is the order of tensor. 3 then power x is equal to number of elements. Number of elements in 3D case. Number of elements 1, 2, 3, 4, 5, 6, 7, 8, 9. So x is equal to 2, that is order of tensor. So if anybody asks you what is the order of tensor of stress, it is 2. Stress is not a vector. Stress is not a scalar. Why not vector, sir? It has direction. Sir, normal stress has a direction, sir. Sir, shear stress has a direction. Go. It has no, because guys, it does not follow parallelogram law of addition. They teach wrong in school. NCERT is wrong. What they say is for making stress. Okay, Joshi sir. Okay, they say to make this stress in NCERT in school they teach only two things. It should be having magnitude and direction. No, three things should be there. It should be having magnitude, it should be having direction, and it should follow parallelogram law of addition also. It should follow parallelogram law of addition also. Okay, parallelogram law of addition means if this is A, this is B, then this vector is A plus B. Guys, this is in 3D. This is in 3D. In 2D, how it will be? In 2D, how it will be? See, remove Z from there. Into sigma xx, tau xy. What is Z in 3D? No Z in 3D. No Z in 3D. And here tau yx and sigma yy. In 2D, this Z will not be there. In 2D, total number of elements are? Total number of elements are 4. 1, 2, 3, 4. Distinct are C. Everybody. See, this and this are same. So 1, 2 and either of these two only one is required. So distinct are how much? 3. And order is only calculated in 3D case. Have you got it, everybody? Just put a heart sign if you got it. Just put a heart sign if you got it. Just put a heart sign if you got it, guys. Have you enjoyed the concept or not? Coming to more topics like Poisson ratio, thermal stresses, every revision will be done here only. Each and every revision will be done here only. Come on. Come on, Parag, Gauri, everybody, let me know, enjoyed or not. And guys, please like and share the session so that more and more commandos can join in. Okay, this is not visible, na? In your notes that I'll be providing you, so I'm erasing it. Okay, now, like guys, what is strain? Sir, stress you have taught everything, sir. Their metrics you have taught, the direction, normalization. What is strain? Guys, since we are studying the deformable physics, in deformable physics, guys, in deformable physics, everybody, there is some strain. What is strain? Let me tell you. In deformable physics, guys, there will be some deformations. Length will be changed, either increase or decrease. Suppose in a body like this is a body. I am applying force. The length was L and it is elongated by delta. Why elongated? Because it is deformable physics. Strain is equal to delta by L. My two questions. And you have to write answer in a single statement. Yes, Ahmed Sahab. You have to write answer in a single statement. That you have to write answer like this. A comma B. Don't write two answers differently. On single comment answer I want. First. Okay, hello Mudassir. First one, if I apply a force, of course deformation will be very, very small, not visible by naked eyes. My question is, strain of a body when I apply force is in kilometers or micrometers? Answer you should write here, then comma. What is the strain of a rigid body? Answer you write here. First, unit of strain, it should be in kilometers or micrometers. Second answer, strain of rigid body. Two answers you have to write. First one, what is the unit of strain? And second, what is the strain of a rigid body? Everybody, let me know answers. Come on. It should be in kilometers or micrometers. Okay, strain is unitless. Now everybody is correct. Unit of length cancel. It is a unitless. Strain is always represented in ratio. And rigid body is 0 because rigid body delta will be 0. Good, great. Okay. Now similarly shear strain is also there. Okay, like shear normal strain is this. Shear strain is, guys, when I apply a force on this shear stress, then since it is deformable physics, so it will be changing like this, or it will be changing like this. Okay, so earlier the angle is 90, now angle is 90 minus gamma. Earlier the angle is 90, now angle is 90 plus gamma. So the change in angle is shear strain. Change in angle is shear strain. And here many times you have seen that in books they make this change in angle is gamma na. So this is gamma by 2 and this is also gamma by 2. Earlier the angle is 90, now gamma by 2, gamma by 2. Here also it is increased by gamma by 2 here and gamma by 2 other side. Sir, why you are 100% sure that if change from 90, see, the earlier the angle is 90, sir. Earlier the angle is 90. Now it is 90 minus gamma. So how you are very sure gamma by 2? Because all tau are equal. All tau are equal. Force equilibrium, moment equilibrium. All tau are equal, therefore the deformation will be symmetrical. All tau are equal, therefore deformation will be symmetrical. Therefore, if the total change is gamma, it will be gamma by 2, gamma by 2. And this shear is taken as positive shear stress or positive shear strain, this one. And this one is negative shear stress or negative shear strain. Okay, like stress matrix, we like strain matrix as well. Okay, the normal strain in x direction is this. Okay, what is this? Let me tell you. What is this? Let me tell you. Suppose this is a body and my direction of x is like this, my direction of y is like this, and coming directly to your forehead is z-axis. Okay, sir. Suppose this is a point P on this body and small direction in x direction, small displacement in x direction is u. This body is acted by forces. This body is acted by forces. Small displacement in x direction is u. Small displacement in y direction is v. And small displacement in z direction is w. Small body. P is any random point on it. Small displacement in x direction is u. Small displacement in y direction is v. Small displacement in z direction is w. So del u by del x is called normal strain in x direction. Del v by del y is normal strain in y direction. Del omega by del z is normal strain in z direction. Okay, and here is the shear strain. Now stress strain curve, everybody. Guys, see, whatever we do, whenever I'm saying na, suppose this is a body of mild steel. I am applying a force like this. Initially the length is L0. Initially the area is A0. So whenever I am saying that stress is equal to force by area, that is engineering stress. By default we study engineering stress only. Whenever I am saying that strain is delta by L, initial length L0, that by default is engineering. When I don't say anything, that means it is engineering. Engineering means force by original area. Engineering strain is delta by L0, original length, that is engineering. And by default, whenever I say stress, strain, that is engineering. Okay, there is true stress also. This is engineering stress strain graph. True stress is after some time, see, this is a deformable physics. After some time, this will be like this. Okay, so length is now L, area is now A. So true stress is force by area at that particular instant. And true strain is, epsilon true is, my friends, delta by length at that time. That is true. And guys, this is P by A0 and strain is delta by L0. That is engineering stress strain curve. Now, if you want to find the relation between the two, then my friend, sigma true is equal to sigma engineering into 1 plus minus epsilon engineering, plus for tension, minus for compression. Okay, similarly epsilon true is equal to ln 1 plus epsilon engineering, of course plus for tension, minus for compression. That is the relation between the two. Okay, got it guys? Any doubt? Ritik, 2 classes. Now guys, this is the engineering stress strain curve for mild steel. Guys, might be for any other stress strain curve will be different. Stress strain curve, how much stress will be applied and how much strain will be there. How much stress will be applied and how much strain will be there, that depends on material to material. Might be Abhinav Negi, If you apply stress, might be more strain. Might be undertaker, khali. You apply stress, less strain, less like rigid. So this is the stress strain curve for mild steel. When I apply stress, up to 8 is linear, making an angle theta, and tan theta is also Young's modulus. That is stress by strain. Unless I mention anything, that is engineering stress, engineering strain. See, all the strains are unitless, represented in ratio or percentage. So up to 8 is linear. O to A, linear. Okay, guys, this is linear for mild steel. For copper aluminum, it is not linear. So that depends on material to material, how it is behave. Abhinav Negi is with this much stress, is strain here. Khali and Undertaker, this much stress, no strain, almost rigid or very less strain. Now from this is A is proportional limit. This A is proportional limit. Okay. Now B is elastic limit. This A is proportional limit, up to which it is linear. B is elastic limit. What is the significance of B? B significance is if before B or at B. Strain in stress equation is true or injuring. This is injuring. If you remind it, na, I know I'm not writing, that's why I spoke. Mind is open of mine. B is elastic limit. What is elastic limit? At B or before B, if you remove the loading. At B or before B, if you remove the loading, then material comes to its original position. Whatever the length earlier, that length, zero strain. But if somebody, some Golu Molu, some Hirolal, stress it beyond B, beyond elastic limit, and then he release the loading, then it will be permanently elongated or permanently compressed. That is called permanent set or permanent deformation. So if before elastic limit you remove the loading, it comes to original position. Otherwise, the dimensions will be changed. C is upper yield point and D is lower yield point. After C, na carbon atom slips. So stress is internal force by area, na. So it will be decreasing. Carbon atom slips, internal strength slips. Now D to E, guys, D to E is called plastic region, in which there is no volume change. Guys, volume change responsible, na, sigma. Sigma is the responsible for volume change. And there is no change in sigma, constant, so no volume change. And shear is responsible for shape change. We just saw it, yeah. Shape is change. So sigma is responsible for volume and this is for shape, shear. Now D to E, no volume, no sigma is changing, neither above nor decreasing, so volume will be constant. It is plastic region. Means the material is so much dull now, material has so much less strength now, that it is elongating without any increase in stress. Now when I was student, what I found, what I think of this, you also, most of you are also thinking like that. We actually, this region, please see, this region we think, we assume, how many are thinking, please let me know. When I was student, I also thinking the same. We were thinking that without any force strain is happening. You are thinking this, please tell me, you are thinking this, without any force strain is happening. Material is so much dull that without any force stress is happening. Are you thinking the same? Because I thought the same in my college. Are you thinking the same, that without any force strain is happening? Are you thinking the same? Are you thinking the same, guys? Please let me know. Are you thinking the same or some different? Okay. Guys, yes, no, I was also wrong that time. This region means that at constant stress strain is happening. Force is there. With force only strain is happening. It is at constant stress strain is happening. But we think, when I was in college, you also thinking the same, that zero stress strain is happening, with zero force strain is happening. No. With zero force strain is happening, that is fluid. If with if with zero force strain is happening, that is fluid. That is zero stress strain is happening. Okay. Now from E, crystalline structure changes. At E, crystalline structure changes and material starts imparting resistance for further deformation. Crystalline structure changes. Now after E, they arrange molecule, rearrange themselves. Somebody is beating me and my friends. Okay, I'm beating. After E, now we again rearrange ourselves again. Now come. Okay, so after E, crystalline structure of mycelium changes, and it changes in such a way, that for further strain, we have to apply the stress. 10% means if somebody is 1 meter, then it is elongated by 1.1 meter, 0.1 meter elongation. Now for further strain, it is not easy like this. You have to apply the more stress. That is strain hardening region. It is not easy strain like this. With further deformation, you have to apply the stress. And that is the ultimate stress. After FG, now material will fail. That will be necking region. Having cup cone failure at 45 degree. Necking region means when it will be failing something like this. This is cup cone failure at 45 degree, and this is necking region. When I mean increasing, the diameter is reducing, it will reduce like a neck. Okay, and it will fail. This is necking region. Have you got all of you? Okay. Now for brittle material, always remember concrete is a brittle material, very commonly used for a civil engineer. Sagnik, Hindi, I'll be telling in Hindi channel, where today 9 PM me and Chandan sir are coming in Hindi channel. So guys, this is sigma, this is epsilon. Now for if brittle material, concrete, always remember that brittle material are very strong in compression, like concrete, and very weak in tension. So compression, guys, is here I am making tension graph, and here I am making compression. So tension they will fail very easily with very less stress. It is failing, and with compression it is failing with high stress, because brittle material has high compressive strength. Okay. Now for different grades of steel, guys, this is mild steel with less carbon. Then with more carbon it will be like this. Then with more carbon percentage it will be like this. Then more carbon percentage it will be like this. What you observe, as carbon percentage is increasing, guys, ductility is decreasing. Young's modulus is same, and ultimate strength is increasing. This you can observe. See, Young's modulus is tan theta. Since initial graph all are overlapping, so Young's modulus is same. This is less carbon percentage, more carbon. When the carbon percentage is less, it is failing at high strain. So more ductile. With increase in carbon percentage, it fails at less strain, less ductile. Even more less ductile. So ductility decreases. But strength it can take more. So ultimate strength is increasing. Got it or not, guys? How is the Josh, commandos? Is it increasing or decreasing, everybody? How is the Josh, friends? Please let me know. How is the Josh, my friends? Everybody, please let me know. Are you getting it or not? Josh, everybody, guys, come on, like and share the session. Let more people join in. Let more people join in, guys. Come on. Okay. So now stress strain curve for brittle material. I've told you for copper and aluminum, na. For copper and aluminum, stress strain curve is like this. For copper and aluminum, stress strain curve is like this. Okay, so guys, there is no yielding point. Like in carbon you can see, in mild steel you can see yielding point. This is yielding point. So this is sigma y. But here you can't. So no sigma y is here. No yielding. So how to find sigma y? What we will do now? We will go to 0.2% strain here. 0.2% strain and draw a line with theta angles. Now sir, what is theta? Initial slope now of this curve is theta angle. So we'll draw a line. Whatever this stress will be coming, we will saying 0.2% proof stress, 0.2% proof stress, or we will be saying it to be sigma y, yield stress. So like this, yield stresses find out here. Got it? Got it? Everybody? Okay, so what is elasticity? I already told you. When material regains its position, that is elasticity. Okay, I already told you guys. When material regains its shape, that property is called as elasticity. Okay, plasticity is characteristic by which it goes in elastic strain. Okay, by which it goes in elastic strain beyond the strain at elastic limit. That property, yeah, this one, that one. Okay. Now creep is, guys, see, everybody, what is creep? If suppose this is the load and applying the load P with the application of P load, since it is a deformable physics, so it is strained like this. It is strained like this. Now this strain is suppose 0.01 mm. 0.01 mm. If this strain is as it is for 3 years, if this strain is as it is for 3 years, then there will be further strain. That further strain is called creep. When the load is for over and time for long time, the further strain will be there, that is creep. Okay. Now fatigue is deterioration of material with cyclic loading. Suppose this is, let me tell you that suppose this is the copy, my hydrology notes. So I am doing like this, 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 I am doing repeated cyclic loading. And when it fails due to this cyclic loading, that is fatigue. And of course, if more is the number of stress, when less number of cycles will be there. If less is the stress, more number of cycles will be required. And if very less is the stress, very less, just touching, in the infinite cycles also will not make it break. Okay. So if I make a graph like this, here is the number of cycles and here is the stress, then graph will be something like this. If more is the stress, the number of cycles will be less. If less is the stress, number of cycles will be more. If less is the stress, number of cycles will be more. And there is also a stress called endurance limit. Below this, there is no failure. Even infinite number of cycles, there will be no failure. Okay, resilience is there's a material, any material, then it's up to elastic limit now, whatever is the area, that is resilience. And toughness is total area is toughness. Might be any curve, curve is like this. The total area is toughness, modulus of toughness. Might be any curve, might be curve like this. For mild state is like this, up to yielding, that is resilience. Sir, what resilience shows, sir? If the area is more, then what to do, sir? What is the feeling? Okay, sir, we understood that area up to yielding point is modulus of resilience. Area up to last point is modulus of toughness. Okay, sir, got it, sir. But tell us the feeling also, na? It's sir, area up to only the partial area, only up to yielding. That is, sir, this. That is, sir, this. What is called? That is this yield stress. and area up to last point fracture is modulus of this toughness. Okay sir, but what is the feeling? No Mudassir. Impact stress is double of the static stress. Whatever stress we are doing na, guys, see, let me just tell you in very short. What is the normal stress here? P by A, but sigma sudden will be 2 times of this. Whatever stress we study in SOM, all are static stress. P by A, force by area. Sigma sudden will be twice if the impact is from zero height. Now see, this area under stress strain curve is strain energy per unit volume. That is also correct. But what is the feeling? That area is strain energy per unit volume up to yield point. That is strain energy per unit volume up to fracture. But what it feels? Guys, the significance is, let me tell you. No, Sandeep Kumar, this is strain energy per unit volume. Okay, but what is that? Is not the significance, na? That is not the significance. I am Abhinav. What is the significance of Abhinav? My home name is Abu. So Abu is not a significance. Na? You have to tell that Abhinav is teaching in BYJU'S Exam Prep, civil engineering. He is teaching nice, he is teaching bad, whatever you like. That is the significance, na? Okay, so this is name is modulus of resilience. This name is modulus of toughness. Then you are saying strain energy per unit volume. That is the name of home, Abu. Okay. So significance is, if this area is more, then that material is suitable for springing action. That material is suitable for springing action like bike shockers or car shockers. So whenever a company, Mahindra, Maruti Suzuki, BMW, Mercedes, whenever they have to make a shocker, those materials will be good, those who are having larger area. If less area, nah, not good for springing action. Understood? Understood, sir, here. What is this? Oh yeah, Mudassir, you are correct. You are correct. Mudassir, you are correct here. I know now what you want to say. If this area is more, na, then it can absorb more energy for fracture. If this area is more, suppose this smart board, I have to break this smart board. This is a very costly smart board. Smart board comes very easy, cheap also, but that is very costly, 5 to 6 lakhs, I guess. Now, if I have to break this smart board, okay, guys, if somebody is watching from my office, don't worry, I'll not break it. Some video team specially. Suppose now you have to break this smart board, and if the area of this smart board is more, area means this stress strain curve area, then I have to apply more energy before breaking it, before fracture. And if the area of stress strain curve up to fracture is less, then with less energy it will be break. Got it or not? Everybody please let me know. Have you got it? And guys, please like and share so that more and more commandos can join in. Everybody please like and share so that more and more commandos can join in. Everybody. Okay. Great. Now hardness is ability to resist against scratch. Scratch should not be coming. That is hardness. Elastoplastic means first like elasto, then plastic. Okay, elastoplastic, elasto, then with strain hardening. Not easy plastic like this. Plastic with strain hardening, so that for strain you have to apply the stress as well. Not as easy. Okay. Now ideal rigid is like this. What is the Young's modulus of ideal rigid? Young's modulus, either you can see this 1090, it is infinity, or you can see stress by strain. Strain is 0, so Young's modulus will be infinity. Okay, ideal fluid is without stress, strain is happening here. Come on here, guys. Without stress, this is fluid, strain will be happening. Without stress, strain will be happening. Got it or not? Everybody please let me know. Have you got it? Any doubt? Anyone is having? Okay, soon we are coming to the courses. After every chapter finish, it will be coming. Okay, this is the Young's modulus relation. That, guys, today 9 PM we are again coming on Hindi YouTube channel. 9 PM today. Now Young's modulus is normal stress by normal strain for uniaxial loading, it is only defined. Okay, shear modulus is shear stress by shear strain. No, Young's modulus is normal stress by normal strain. Young's modulus is normal stress by normal strain. Shear modulus is shear stress by shear strain. Okay, bulk modulus is hydrostatic stress upon volumetric strain. Hydrostatic stress means suppose the body is like this, then triaxial stress from here sigma is coming, here sigma is coming, from here sigma is coming. What is the change in volume? Okay. Then Poisson ratio is lateral strain upon longitudinal strain. What is lateral? What is longitudinal? What is lateral? What is longitudinal? Guys, if suppose this is the force I am applying, then in the direction of force, not the bigger side, not the bigger side. Whatever the force is acting, that direction is longitudinal and other is lateral. Okay, the mu value is like this from 0 to 0.5 for metals. If they ask question for metals, it will be from 0 to 0.5. If they ask for any material, it will be from -1 to 0.5 because human tissues and soap polymers can have minus also. Relation between Eg mu k will be like this. Okay, independent elastic constants are total are 4 for isotropic. Independent are 2. Because suppose you know k and mu. So E can be find out. Once E is find out, mu you already know, so G can be find out. Okay, any two, not necessarily K and mu. Suppose K and G. With K and G, E can be find out. With K and G, mu can be find out. Okay, great, great. So number of independent elastic constants 2, here 9 and here 21, but that is only in our syllabus. Okay, uniform sections that I'll tell you with the help of questions. Okay, mu we have done. Guys, when suppose temperature is increased, so length will be increased. Okay, delta L is equal to L alpha delta T. Delta in B is equal to B alpha delta T. Change in depth is equal to D alpha delta T. Okay, so there will be no stress at all. When a body is, we apply a temperature, body can elongate, no stress. Guys, soon we are coming with the questions. Please sharpen your pencil. Okay, total elastic constants are 4. For other Mudassir, isotropic and isotropic not in syllabus, not required. Yes, Mansoor Ahmed. Alpha is this. Now, guys, when I am applying the temperature, if you are able to, yes, if it can increase, nobody is restricting them, no stress at all, no stress at all. But suppose it is fixed. Now I am applying increase in temperature. It wants to increase but not able to increase. It wants to increase but not able to increase. In that case, stress will be coming. That will be E alpha delta T. Suppose you are heating it, increasing the temperature. Suppose you are heating the temperature. So it will be compressive stress. It will be compressive stress because it wants to elongate. It wants to elongate, but supports are fixing it. No, don't elongate. No, don't elongate. So compression will be there. And if temperature is decreased, it wants to shrink, but can't shrink because it is fixed. मजाक थोड़ी नहीं चल रहा है. It wants to shrink, but supports will not able to shrink. Will not allow it to shrink. So it will pull it back. So stress will be tensile. Because it wants to shrink, but supports will pull up. No, don't shrink. You can't shrink. I have hold you. So it will be tensile. So this all things will be written here. Composite will be what happening now. Composite and fixed are two different things. Fixed means delta can't be 0. Delta can't be there. Delta 0. Fixed means delta 0. Elongation can't be there. Fixed means elongation can't be there. And composite bar means delta is equal to same. Elongation or contraction may be there, but it will be same. Okay, now what happens? What students do mistake in exam? Let me tell you. Here, guys, it will increase both sides. It will increase both sides. For simplification, I am telling you only one side. It will increase both sides. Okay? It will increase both sides. But for simplification, I am telling you it is increasing only one side. Now, suppose alpha 1 is more, so it will, if it is free, there is no restriction. So 1 will increase more or 2 will increase less, but both will increase because temperature is increasing. Both will increase. Both will increase. Both will increase. If it was free, no, it will increase both sides, guys, left and right both. I'm just for simplicity I'm telling you only one side. Okay, now since it is composite, delta has to be same, so it will increase to this point. They will make a compromise, not this much long, not this much short, it will here. So first bar will go back. It wants to increase up to here, but it has to restrict itself, so compression will be there. It wants to increase here, but now it won't have to increase up till here, so it has to pull up. It wants to increase up to here, but it has to pull up, so tension will be there. And in temperature decrease case, it will be vice versa. Okay, sir. Now, what students do mistake now? Many times I have asked them questions. In exam also it is come. If this is the case, this is 1, this is 2, temperature is increased. Again, alpha 1 is greater than alpha 2. Which is in compression, which is in tension here? In fixed case, which is in compression, which is in tension? Please let me know answers on the comment box. Please let me know the answers on the comment box. Each one of you. Each one of you. Let me know. Yes, I'm checking your answers, guys. Come on. Come on, come on, come on. Come on. Guys. Yes, yes. Guys, come on, reply, yaar. In fixed case, what will be there? Great. Oh, come on, Shashi. Guys, here it wants to increase more. It wants to increase less because alpha 1 is more. But delta is 0. Both can't increase. Not a little. So it will go back here, it will go back here. Compression, both will be compression. Got it now, Mudassir? And similarly, temperature decrease case, it will vice versa. Got it now? No. You are, guys, come on here, grow up. I just said you before starting this topic that here students do mistake. Then also you are doing mistake. Come on yaar, ऐसे कैसे चलेगा? Come on yaar. How this will work like this? I just told you the students do mistake here, then also you are doing mistake. Got it now? Please be ready with the questions. Very soon the questions will also be coming. Now these are questions and 90% questions will be the new. Now everybody let us know how many you have understood the things, how many you have known the things earlier as well. A steel bar of cross section this and 2500 mm long. This is 2500 mm long. Okay, and this is 40 into dimensions is of this dimension is 40 into 40. 40 into 40. Okay, subjected to axial force of 130 kilonewton. Subjected to force of 130 kilonewton. Axial means the longer one. If the modulus of elasticity is given, this is E, and Poisson ratio is given 0.35. Okay, the alteration in the length and sides of the bar during the extensions are. Okay, everybody, what is in this direction? Alteration in length. Epsilon L is equal to delta L by L. Okay, now epsilon L is equal to sigma by E. Sigma by strain, that is delta by L. So delta is equal to sigma by E into L. So sigma is force by area. So 130 by area. Area is 40 into 40. Make in proper units. Make it in proper units. Upon E. Upon E is known. And length is also known. Any doubt here? Any doubt here? I'm not wasting time in calculations. I'm not wasting time in calculations. Okay, sir. Got it? Now, suppose this is x direction, this is y, and this is z. Okay? Now, please see epsilon y upon epsilon x minus of lateral upon longitudinal is Poisson ratio. Minus of lateral upon longitudinal is Poisson ratio. Everybody. So minus epsilon y is equal to epsilon y is equal to u epsilon x. So epsilon y is equal to minus mu epsilon x. So epsilon y is change in y direction, that is lateral. Delta y upon length there is 40 minus mu, that you know, and epsilon x also you know yaar, from here. Epsilon x also you know from here, that is sigma by E. 130 upon 40 into 40 sigma upon E. E you know. From here you can calculate, it will be minus, because if one is increasing, another will be decreasing here. Come on. See, if one is increasing, other will be decreasing. Of course. So, of course, if this is a tensile stress, if this is axial pull means tensile. So, this can't be answer. How it can be in minus? Axial direction. Okay, length how can be in minus? If there is a pull, it will be elongation. So, like this also we can do. And guys, here also without any solve you can do it yaar. Without any solution you can do. Let me tell you. There is a pull in the length, pull. So how it can be minus? It will be elongating. So cross. Again, if there is a pull here, it will be elongating here. Other direction it will be compressing. Other direction it will be compressing. So is here also both can't be plus also. So directly 8. Full solution is like this. Now this one. Volumetric strain. Sigma x is compressive minus 30. Sigma y is 20 and sigma z is 50. E is given, mu is given, volumetric strain is asked. Can you please let me know the answer? Can you please let me know the answers? Everybody on the comment section. Everybody on the comment section. Okay. So volumetric strain is sigma x plus sigma y plus sigma z into 1 minus 2 mu by E. By E. Sigma x is known, sigma y is known, sigma z is known, mu and E are known, so you can find out. You can find out. C or A, whatever is the answer that you can do. That you can do. Now this one, a uniform bar fixed at one end, okay, and free to move in the other end, like this. Free to move in the another end. If the temperature of the rod is increased by T, neglecting the gravity effects, the rod will develop Guys, see, temperature is increased, gravity effect is not there, so there is no vertical mg. There is no vertical mg because gravity effect is neglected. So it want to increase here, it will increase here, none. No stress. Why the stress will be coming here? Why the stress will be coming? There is no mg also. There is no gravity effect also. Okay, this take as a homework. Okay, again assignment. This assignment I am giving to this. Okay, assignment, maximum shearing, this you all know, homework. Okay, let's come to chapter number 2. Ready? Let's come to chapter number 2. SFD BMD, AN method will be coming here. AN method will be coming here. Are you all ready? Are you all ready, guys? Okay, so first of all, for stability na, minimum number of reactions should be 3. All should not be parallel, all should not be concurrent, might not be passing from the same point. And reaction, see, you will only say the condition to be in equilibrium when the supports are self-sufficient to take the load. If supports are very weak, then also it will not be equilibrium, it will be breakdown. Okay. Now this cantilever beam, one fixed, one free, simply supported like this, one time pin, one time roller. Propped cantilever means one time fixed, another time it is roller. Okay, fixed beam, both sides fixed support, continuous beam, more than one supports. 9 p.m. we are coming today on Hindi channel. Now significance, shear force is this, bending sign convention. Now let us come to AN method. Everybody ready? Everybody ready? Everybody, always we go from left to right. Ready for the AN method? How many of you know the AN method? First of all, let me tell this. Concurrent means all going through the same point. Like this is concurrent. This is a beam and here it is like this. So reaction, reaction, reaction. If all the reactions are passing to the same point, so that is concurrent. Now if we apply the force like this, this will rotate. Guys, how many of you know the AN method? Those will get the revision. Only 2. Only Lavanya, Nitish and Aman. What about others? Guys, please like and share the session so that more and more commandos can join in. If you have not liked till now, please like. Let more people join it. Let more people join it. Okay. Guys, Abhinav Negi method is like this. Please see that any difficult question in this world, you can draw the SFD. Any difficult question in this world, you can draw the SFD in 30 seconds. Or not 30, even 10 seconds and draw the BMD in 10 seconds. Any difficult problem. Draw the SFD in 10 seconds, draw the BMD in 10 seconds. Very, very easy. Okay. Bending, just few points you have to remember. Any question, and these are not tricks. If they were tricks na, then it is only valid for few problems. These are all derivable things. I'm not deriving here, of course. These are all derivable things. Okay. So it is valid for every year. Whatever I am telling you, that is valid for every year because these are derivations, not tricks. Okay, this slope is, the graph of this slope is positive constant. See, it is acute angle. Acute angle is positive. Okay, constant. This is also acute angle. Constant, but it is, slope is decreasing. Like this, more angle, increasing, but acute angle, positive. So obtuse angle tan 120, tan 130 is negative. Okay, here it is obtuse angle, negative, magnitude wise decreasing, like this. Okay, guys, see, one more thing I am telling you. If you want more detail, then you can see here in Maha Marathon, I will be revising it. In Maha Marathon, I will be revising it. If you want the complete AN method, then you can see particular video where I have taught 1 hour only this. Okay, guys, this is not Abhinav Negi method. I always tell every time that yes, I was one of the first one who started using this method 10 years back or 11 years back, but that time nobody is using this method. That time everybody is doing with long cut except 1 or 2 people in the country. But yes, now many people are using this. Okay. Okay, now let's see how many people are there right now live. It's 115. Okay. Guys, guess who is here with the AN method? Guess who is here? Call तो आएगा नीचे से उधर गार्ड का. Guys, who is here? Any guesses? All the who are here from the beginning, they already know this. Who is here? With AN method just after this I am going to the AN method. I'll solve all of these. Everybody. Any guesses? L by 2, it is symmetrical, so it will be P by 2, it will be P by 2. Just before entering, let me all finish this table, then the superstar will be entered. DE, this is W Newton per meter. At center there will be some F. Okay, so total this L length in 1 meter it is W, and L length WL, so it will be WL by 2. Guys, superstar will come and when I fill this table. So this is B, D, F, G. Okay, GH, so there will be some reaction RG, there will be some reaction RH, not wasting time for calculating the reactions. Now, here, okay. Ready to meet him? Just let me, here I'll be making SFD. And here I am making BMD. This is A, B. This is D. This is E, somewhere between F. This is D. This is E. This is G. This is H. This is G. This is H. Here I'll be making SFD. Here I'll be making BMD. Here I'll be making SFD. Here I'll be making BMD. Okay. Welcome. Good morning. Okay, Atul is also here. Guys, share the session everywhere. Superstar. And guys, let us make it like the session here. Let the superstar come with a huge number of likes. Okay, where is the mic going here? Okay, now guys, 5-minute motivation from him. Then we'll be doing the AN method, guys. Okay, everybody please put a heart sign for Joshi sir. Everybody, come on. Okay, welcome sir to my home.
Hello sir.
Okay.
So hello everybody. How are you all? So I hope you all are doing great. And I was just watching this session since morning only 10:30. मैं train से देख रहा था. And I hope everything is going super, and I'm not hoping, I can see everything is going super fine. And in this particular situation, in this particular duration, then when you can say very less time is left, you are getting very detailed revision, right? Very detailed revision. So I think you all are full power hitting the like button and sharing the session with each and every friend of yours, right or not? Right? How's the Josh? Everybody is here now. Okay, so we are here. Why we are here? We are here to give you the best of the best revision that you can ever have before your examination. And 5 p.m. today, you can see that's me with fluid mechanics for you all in 2 parts. As you can say, sir is also completing so in 2 parts. So we'll be doing the FM in 2 parts. I'll see you 5 p.m. Okay, I'm full power ready now. Right? बस अभी थोड़ा सा बस भूख लगी कुछ खा के फिर I'll take the session. Right? So everyone is doing great. बढ़िया. Hi. सही चल रहा है. देख रहे हो? देख लो. डॉन सर. अरे भाई.
Okay.
Thank you.
Okay. So that is not that is steel glass. Inside can be anything. Okay, guys. Let me just wear the mic again. पानी में आग लगाए. Okay, that is not allowed. Hello? Guys, voice is coming? Voice problem. Hello, 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 hello. 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 Is it voice coming now? Hello. Hello. Guys, voice is coming? Now okay. Now it's my phone is coming. Joshi sir has put some virus, I guess, here. Okay, in between, if voice again goes, please let me know. Okay, so let's make it 140 people at the end of this. Starting AN method. Okay, if any voice breaks in between, please let me know. And for next 7 to 8 minutes, no comments. Just enjoy. Next 7 to 8 minutes, guys. Okay, either you put heart sign, no comments. Either put heart sign. After that, I'll be taking your doubt. Okay, I guess now it's fine. I guess now it's fine. 2 minutes, no comments. Just enjoy. Next 7 to 8 minutes, guys. Now his voice is fine now. Okay. Okay. Everybody, please see. AN method. Here first SFD. While drawing SFD, you have to see loading diagram. While drawing BMD, you have to see SFD. While drawing SFD, you have to see loading diagram. While drawing BMD, you have to see SFD. While drawing SFD, you have to see loading diagram. While drawing BMD, you have to see SFD diagram. Everybody, 123, like let's make 140 or 145 after AN method. Okay, let's start. 1, 2, 3. Okay, see upward load P by 2 at A. Guys, just put a heart sign, no comments now. Put a heart sign or no comments. After that, I'll be breaking a doubt. Even you don't like, then you don't put heart sign. If you like, put a heart sign in between for my motivation. And at the end, I'll be taking your doubts as well. Let's start the AN method of SFD BMD. 3, 2, 1, let's start. Okay, see here in the first figure, at A there is upward load. At A there is upward load P by 2. A upward load P by 2. A upward point load P by 2. A upward load P by 2. Upward load P by 2 shear force jumps. 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 Okay, sir. So shear force jumping to E. From P by 2 it will be jumping. From P by 2 it is jumping. Okay, from A to C no load. 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 Okay guys, no load. So no load means the load intensity. No load. Load intensity is 0. So shear force slope is 0. Shear force slope is 0 because no load now from A to C. From A to C there is no load. No load means load intensity is 0. So shear force slope is 0. Shear force slope is 0. That means shear force slope 0 means that is straight line. Straight line is having a 0 slope. Okay, got it guys. Then there is a downward point load P. Then there is a downward point load P. Downward point load P means downward point load shear force falls. Downward point load shear force fall. Downward point load shear force fall. Downward point load shear force fall. It will from plus P by 2. It is falling by P. So it will reach minus P by 2. It will reach minus P by 2. Okay, from C to B no load. 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 No load means load intensity is 0. Load intensity 0 means it will be straight line this. Straight lines because straight line has 0 slope. Now upward point load shear force jumps. 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 Again upward P by 2 it will jump and it will be SFD. Okay sir, got it sir. Now coming to BMD. While drawing BMD, we have to see SFD. While drawing BMD, we have to see SFD. Everybody getting yes, everybody. Good. Everybody is putting a heart sign in comment box. Good, great. Now from A to C, it is shear force positive constant. From drawing BMD, we have to see SFD. For drawing BMD, we have to see SFD. From A to C, shear force is positive and constant. Okay, positive constant graph number. Positive constant graph number 1. So like this, twing graph number 1. Graph number 1 is like this. Okay, from C to B negative constant, shear force negative constant, shear force negative constant, shear force negative constant, shear force negative constant, negative constant graph number, negative constant graph number, negative constant graph number, negative constant graph number 4, like this. Okay, sir, got it, sir. Okay, SFD, BMD, AN method, very quickly we are getting. Okay, now drawing for this second figure. Upward point load shear force jumps, 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 upward point load shear force jumps. Jumps by WL by 2, Jumps by WL by 2. Okay, sir. From D to E, it is downward loading. Downward loading is negative. Downward loading is negative. Downward loading is negative. Downward loading is negative. Okay, and constant, uniformly distributed load. Uniformly, UDL. Uniformly distributed load. So downward means negative. Downward means negative and constant. Negative and constant. Negative and constant. Now, why negative? Because downward. Downward is negative. Constant means uniformly distributed load. Uniformly, constant. So while drawing SFD, we have to see loading diagram. While drawing SFD, we have to see loading diagram. Negative constant graph number. Negative constant graph number. Negative constant graph number 4. So it will be like this. Okay. From upward load, shear force jumps. Upward load, shear force jumps. Upward load, shear force jumps. We know upward load, shear force jumps. Yeah, this is this. Okay. So upward load, shear force jumps. It will be jumping like this. So this will be SFD. Of course, guys, if you make like this upward load, it will not be closed. Nothing use of that. Now drawing the BMD. Now drawing the BMD. Now drawing the BMD. Okay. While drawing BMD, we have to see SFD. That's very clear to everyone who is watching like me live now. Okay. From D to F, shear force positive, but magnitude by decreasing. More, less, 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 less. Positive but decreasing magnitude wise. Positive but decreasing. Positive decreasing graph number. Positive decreasing graph number. Positive decreasing graph number. Positive decreasing graph number 2. Graph number 2. Graph number 2 like this. Tweet. Okay, from E to F to E, it is negative, but magnitude wise -5 is bigger than -2. Magnitude wise -5 is bigger than -2. Magnitude wise more. Magnitude wise increasing. So it is negative magnitude wise increasing. Graph number. Negative magnitude wise increasing. Graph number. Negative magnitude wise increasing. Graph number 6. Okay. 6 will be like this. You have seen 6 will be like this. Kahan gaya? Negative magnitude wise increasing. Got it, sir. Got it, sir. आप बैठो ना जोशी भाई. Okay, Joshi sir, please. आप पीजिए चाय. Okay. नहीं आप बैठे. Okay, so from G to H, third figure. Okay, upward load. I'm not calculating the load that you can calculate. RG upward load, shear force jumps. Upward load, shear force jumps. Upward point load, shear force jumps. Come on here. Upward point load, shear force jumps. 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 So upward point load, shear force jumping like this. Then from G to H, loading is downward. Downward is negative. Negative magnitude is increasing. 2E. More. Guys, we have to go left to right. More. Negative and increasing. Loading is negative and increasing. Negative increasing graph number. Negative increasing graph number. Negative increasing graph number. Graph number 6. Okay. So it will be like 6 to E like this. Now at H, upward point load, shear force jumps, like this. Plus minus, let it G, H, let it name B. Okay. Joshi sir, he is here. Let it name be J. Okay. So DJ, bravo. Now from G to J, from Goa to Joshi sir. Shear force positive but decreasing. Less. G to J, it is positive and decreasing. Graph number. Positive decreasing graph number 2. Positive decreasing graph number 2. Like this. Graph number 2. Okay. From Joshi sir to Haryana. J to H. It is negative but magnitude wise increasing. More. Magnitude wise increasing. So J to H, negative and increasing graph number. Graph number 6. Okay. So like this will be BMD. Guys, there are various other points that we'll see later, that whenever shear force is 0, bending moment is maxima or minima. One more point for symmetrical figures, symmetrical loading, symmetrical supports. Guys, BMD is symmetrical always and SFD is anti-symmetrical. See, symmetrical figure, SFD anti-symmetrical, BMD symmetrical. See, symmetrical figure, SFD anti-symmetrical, BMD symmetrical. That is not symmetrical figure. And if the degree of loading is n, then SFD degree will be 1 more, n plus 1, and BMD degree will be n plus 2. Why, sir? Why, sir? Come on, come on. Differentiating, we are getting shear force. While differentiating, we get 1 degree less. Suppose any function is y is equal to 3x cube plus 7. So differentiating it will be 9x square. So 3 degree, 2 degree. Again differentiating it will be 1 degree less, 18x. So if this degree is 1, is anything, it will be 1 less. Again it will be 1 less. So if this degree is something, 1 less, 1 less. Getting or not? Everybody please put a heart sign if you got it. Everybody please put a heart sign if you got it. Otherwise, comment me your doubts. Everybody, now it's your turn. Thank you. Still left. Many things are still left. Just let me know. Let me know, friends. Have you got it or not? Have you got it or not? Please put a heart sign if you understood the things. Vivek, Nitesh, Tiksha, Patil from Narela. Tasmai. Everybody, come on, do one thing. Sir, can we use AN method for drawing loading diagram from... Yes. Reverse, in the reverse way. Just one more thing, guys. Varsha, thank you. Just one more thing. Just please let me know how many of you... please write down your cities. Let us check from where the people are here. Let us check from where the people are here. From which part of the country. And watching me. Everybody. Please. Okay. One for cantilever, okay. Let us do for cantilever. Hyderabad, Dheeraj. Hyderabad. Kerala. The heaven. Nagpur orange. Orange burfi is very good. Karnataka. Visakhapatnam. Mirzapur. Ladakh, oh my god. Andhra Pradesh, Indore, Chappan Bhog, Sarafa, Trichy, Siliguri, oh, I have been to Siliguri a couple of times. Agartala, Tripura, Odisha, Patnaik, Coimbatore, Andhra Pradesh, Vizag, RK Beach, Rishikonda, Mumbai, Morbi, Bihar, Andhra Pradesh, Balaghat, Warangal, Dehradun, excellent. Bihar, Patna, whole India, from the Ladakh to Tamil Nadu, everybody is here, and from Agartala to Gujarat, everybody is in the comment box. Great. Okay. Now, okay, somebody has asked. This you can take as assignment. I'll be sharing this in my Telegram. You can take this as assignment. Somebody asked me for cantilever. Okay, great, good. I like your doubts. Cantilever kahan banaun? Here, let me make here. Suppose this is... let me use smartboard. Can delete. ये अब नहीं मिटेगा, I guess. Yes. Okay. Suppose this is cantilever, and in cantilever you want point load or UDL. Let me make it difficult. Let me make it more difficult. Let it be loading like this. UVL. Okay, let it be A. Let it be B. Let it be W. So total, you can find reaction and movement. I'm not wasting time in that. Total load, that is half base into height. This will be half LW. Half WL, but you can find it. I'm writing RA only. Similarly, movement also I'm writing MA. Now SFD, you have to see loading diagram. Okay, upward load, shape for jumps, upward load, shape for jumps, upward load, shape for jump, upward load, shape for jump, dumping like this, dumping like this. Okay, Ale, so it will be dumping by Ale. You can find the value. Okay, now the loading is downward is negative, and magnitude wise increasing, left to right, magnitude wise increasing, negative and increasing graph number, negative increasing graph number 6, negative increasing graph number 6. Okay, so negative increasing graph number 6, it will be like this. SFD will be like this. Everybody got it? Yes. Now BMD. For BMD we have to see SFD. First of all, there is an anti-clockwise movement. So anti-clockwise movement BMD falls. कहाँ गया? Anti-clockwise movement, like downward load shear force fall, na anti-clockwise movement BMD falls. So anti-clockwise BMD falls like this, tui 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 tui. Then shear force is positive but decreasing, less. Positive decreasing graph number, graph number 2, like this. This is 1 degree, so this will be 2 degree, this will be 3 degree BMD. Everybody give me Y or N. Have you understood? These are all your assignments. Shall we go to the third chapter? Everybody enjoying till now? And let us do one thing. In this session we'll be doing up to only bending stress and shear stress. Then from tomorrow we'll doing Mohr circle. Understood or not? Please let me know. Any doubt if you are facing till here? You are most welcome to ask. Great. Okay. Now see, these were very small chapters, na? Very small chapters, you will be getting it. Please see. Suppose this is a beam, and in this beam it is acting by a moment M here. This is called pure bending. What is pure bending? When there is no shear force. What is pure bending? When there is no shear force. So bending moment is constant, na? BMD will be like this. Clockwise movement BMD jump, anti-clockwise movement BMD falls. So bending moment is constant. So dm by dx is shear force. If m is constant, then shear force is 0. Okay. So this is called pure bending. All the formulas that we study in this chapter is applicable for pure bending. However, we will apply it everywhere. Now this will deflect into an arc of a circle. Sir, why you are very sure? Because guys, I'll tell you later. Let me tell you later. This is compression at the top and here tension. Guys, not always compression at top and tension at bottom. For sagging movement, suppose the movement is like this. There can be tension at top and compression at bottom. Got it? Yes. Great. Okay, Akshat is saying something in my telegram. Akshat, how I can handle this class with so many students, and your reply also might be some issue. I don't know what happened. You guys, you can all join me in telegram. I've shared the link. Okay. Now moving forward, please see. So this compression will be coming and here tension will be coming. So here is compressive stresses and here is tensile stresses. But these are not stresses due to some force. It is not P by A. There is no force acting. These are bending stresses. These are not force by A. These are bending stresses, and bending stresses are like this. At neutral axis, suppose the section is like this. So neutral axis, centroidal axis. Total depth is D. So centroid of rectangle is at D by 2. And for triangle it is 2h by 3, like that. Okay, Akshay, thank you. So these are bending stresses at y distance from neutral axis. Suppose, let me make a bigger figure. Suppose this is the cross section and neutral axis will be centroidal axis. Total depth is D, so neutral axis will be centroid. It will be D by 2. For triangle it will be 2h by 3 and h by 3. Whatever is the centroid, not the mid depth but centroid. So above it is compression for this kind of movement, and here is tension. So these are the stresses. These are bending stresses, guys. Bending. There is no force acting. It is not P by A. The father of this is M. not P. There is no P force. There is M for bending stresses. Okay, at any distance y from the neutral axis, if stress is sigma, that is given by sigma bending stress at y distance from neutral axis. M is the moment at that section, I is the moment of inertia, E is the Young's modulus, and R is the radius at which it is bending. Again, I am saying sigma is the stress at y distance from neutral axis. So if suppose y you put something different, y dash, then you will get sigma dash. Sigma is the bending stress at y distance, M by I, moment upon moment of inertia upon Young's modulus upon radius at which it is bending. Okay, guys, see, M by I is equal to E by R. Okay, 1 by R is also called as curvature, is equal to M by EI. For pure bending, M is constant. For pure bending, M is constant. And prismatic, if somebody says prismatic beam, then EI is also constant. If somebody says prismatic, then EI is also constant. So M is constant, EI is constant, so radius is constant. So it is a circle. So deflected shape is circle, but only the case when this is constant. And this is constant when pure bending, that is M is constant, and prismatic. Got it, guys? Everybody? So 99% question will be coming from here only, this formula only. Can you please do this for me? Can you please do this for me? Everybody? Guys, see what they are asking, force. So stress neutral axis will be at here, mid depth, d by 2. Neutral axis is not mid depth, it is centroidal axis, but for rectangle case it is mid depth only. Samir, yes, you can watch this, it will be totally beneficial for you. Samir, how you like my classes? So here at this blue point, 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 blue point, blue point, blue point, shear stress, bending stress is 0. And this green point, this green point, green point, green point, green point, green point, stress is sigma. Guys, stress variation is along the depth, not along the width. At all these points, stress is sigma. At all these blue points, stress is 0. Stress variation is assumed only in case of depth, not in width. So here the stress is sigma. Okay. So force is equal to stress into area. Stress into area. Area is 50 into 25. And stress is here 0 and here sigma. Here 0 is sigma. It is increasing, 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 increasing. So average we can assume to be 0 plus sigma by 2. Average stress into 50 into 25. What is sigma? So sigma by y is equal to M by I. So M is known, I is BD cube by 12 is known, and y is 25. So sigma from here you will be getting 14.22. Putting 14.22 here you will be getting 8.9 kilonewton. Everybody, please let me know. Everybody, any doubt? Everybody, any doubt? Please let me know. Please let me know. Okay, sir, if these kinds of cases will be there, that movement is also coming and force is also coming. Sir, movement is also coming and force is also coming, then what to do? Movement is also coming and force is also coming, then what to do? Then we will algebraically add. Due to movement, stresses will be like this. These are bending stresses, sigma b, bending. Formula will be coming from M by I into Y. And due to purple, it will be, it is compression. So it is force by area. This is now the first that I told you at the beginning, force by area. P by A. That is called sigma direct. And you algebraically add them. Algebraically add them and get the answers. Any doubt? Any doubt, friends? Let us come to the fourth chapter now. Today's last chapter. Today's last chapter. Please let me know any doubt here. Everybody. Everybody. Any doubt here? Okay. Now guys, see what I told you in the first chapter. Please see that if this is a body with P force, suppose here will be 0.3 P depending upon the distance, and here is 0.7 P, and I cut a section from here like this, XX. Now when I'm cutting the section XX like this, like this, like this, like this, like this, okay, here it is 0.3 P, here it is 0.3 P, and here it is downward 0.3 P. So shear stress is shear force upon area, but that is average shear stress, na? That is average. Actual variation of shear stress is given by this formula. That is same like 200 kilometers you are traveling in 4 hours. So 50 is the average speed, not the actual. You must have been studying in highway. Okay, 200 by 4 is 50. 50 is average speed, not the actual speed. 50 is the average speed, not the actual. So this is average shear force by area. What is the actual is given by this, that if you take any location this, and from neutral axis you go above to any point T, okay, this is the T point at y distance from neutral axis, then actual shear stress, that is the average shear stress for the whole section. Actual shear stress at any point T of that section is given by shear force at that section upon area. Area is area above that, and y bar is the above area, na? What is the center of mass? Similarly, if it is point below, if T is below, then area is this, and y bar is center of this from neutral axis. So A is the area of that point, y bar is the center of that point upon I into B. I is the moment of inertia about neutral axis, B is the width of the section. From here you get the actual variation, and whatever the things you will be getting, guys, always for rectangular section C, I am not going into derivation here. The rectangular, it is like this. It is always 0 at top and bottom, and it is parabolic. It's parabolic, you can derive from that expression, and tau max here is 3 by 2 of tau average. Tau average is shear force by area, S by BD. For rectangle and triangle it is like this, and tau max is equal to 4 by 3 tau average for circular section. For circular section it is 4 by 3 tau average. Okay. Now, can you please make this for me? The questions are asked, figure questions in GATE. This is a very interesting part for students. This is the figure question asked. See, always remember 2 points. It is 0 at top and bottom. It is 0 at top and bottom, parabolic variation. Twing, twing. Suddenly areas decrease. So shear stress is force by area. Suddenly areas decrease. Suddenly areas decrease. So stress will increase. Like this. Like this. Always remember 2 points only. 0 at top and bottom and parabolic variation. Areas increase, stress is decreased. Areas increase, stress is increased. Please let me know this one. Please let me know this one. Please let me know this one. Everybody. Okay, see, it is 0 at top and bottom. It is 0 at top and bottom. Parabolic variation 2e. Parabolic variation, then areas decreased. Areas decreased, so stress will increased. Then parabolic variation. ओके शुभम बफरिंग हो रहा है क्या आपको? शुभम बफरिंग हो रहा है क्या जबरदस्ती? Guys, if there is no buffering and some students are making like this, I'll straight away block them. Straight away. Because that is giving wrong impression to other students. It might be your network issue. Please don't make that sign again because that will be disturbing to students. They're again refreshing it. That can waste their time and their time is my time. My game, my rules. My class, my rules. Okay, Shubham? बफरिंग हुआ तो बनाओ ना, इधर की वजह से, आपके नेट की वजह से नहीं. Okay, again here, shear stress. Guys, values only have to remember for this, 3/2 tau average and for circle 4/3, not for these, for only shapes. See, 0 at top and bottom, parabolic variation, areas increased, so stress will decrease. Areas increase, so stress will decrease, like this. Like this. Have you got it? Have you got it? Please let me know. Please let me know. Any doubt? Any doubt? Okay. Now this one, guys, is the answer is like this. 0 here, 0 here. Areas increase, decrease, so stress will be increasing. Who are saying yes? Please put a Y on the comment box. Now Joshi sir will be coming for motivate you because there is a long class for 5 minutes after this figure. Then we'll do some questions with 5 minutes for his shairi. Joshi sir ready? Okay, just let me finish this. First of all, yes, Dheeraj is saying yes. Jyoti is saying yes. Anaga Babu is saying yes. Yes, yes, yes. Santu is saying no. Why Santu? Tau for rectangular section is 4/3 tau. Roshit, please tear that page and eat popcorn on that. Okay, sir, Roshit is saying that in some books tau max is something different. That is not the correct one. So I said that tear that page, have a popcorn on that. Okay, Varsha good, Naresh Meena good. So Varsha, Naresh, Selvam, Parag were correct. Atul is also correct, and of course Santu Sarkar was also correct. Guys, who are saying yes, that is totally wrong. The figure is this. 0 at top and bottom, parabolic variation. Guys, area is not decreased suddenly. In earlier cases, areas increase suddenly. Suddenly areas here and suddenly areas more. Here area is this and it is decreasing gradually. This portion is cutting gradually, not suddenly. So it will not be a jump. It will be just like this, not a jump. Got it, friends, everybody? Got it, friends, everybody? Got it, friends, everybody? Please let me know and please put a likes, guys. Please like the session and share it with your friends. I'm just sharing one more session with you all. Please like it. Okay, then I'm coming with the questions, with very, very interesting questions. Very, very interesting questions. Okay, guys, everything about MSQ. Everything MSQ today 9 PM. Please like this session, guys, straight away. Please like this session, guys. 9 PM today. 9 PM today. Everything about MSQ. MSQ will not be a mystery after that session. That mystery will be resolved. That mystery will be resolved after that. So waiting for Joshi sir, all of you. Please like that session, guys. I'm wearing the commando t-shirt from inside. Okay, that one. Yes, yes, Sakti. Okay, so I'm handing the mic to Joshi sir. Joshi sir, please handle it carefully. Okay. Now, yes, and please like that session, guys, everybody.
All right, all right. So we have another session also at 9 p.m. sir, right?
9 p.m. 9 p.m. on Hindi
9
channel.
हिंदी चैनल पे है. This one is on हिंदी channel and all of you जिन्होंने अभी तक सब्सक्राइब नहीं किया है, you can also subscribe to the हिंदी channel Civil Champion, or actually it is now grade this BYJU'S Champion, right? So you can also subscribe that channel because we are having MSQ specialist series on that particular session, right? On that particular channel. So don't miss that. We won't.
And guys, see, we are studying for so much time. I guess it is 2.5 hours. Just let us have a 5-minute ask us anything. Okay, to me and Joshi sir.
Right.
Anything you want to ask us, then we can do the questions later on.
Correct. So if you want to ask us anything, you can ask. Otherwise, there are few things that we can tell you that we are getting since we are getting lot of messages. Sir, आपको भी बहुत message आ रहे होंगे students के, and most of these questions are related to the formulas, that how to remember all those formula. So I'll do one favor from your side. I'll ask Abhinav sir that how he used to remember the formula when he was preparing. Sir, what was your strategy?
Sir, actually, to be very frank, if I remember this very exactly, I have no strategy. That time, I was not very that kind of person who is making strategies, going with the flow.
Right.
And one thing I believe that just 2 months before the exam, I made a very thin copy and written some formulas that were frequently asked. And daily I'm revising it.
Okay.
And I totally believe if any student is literally preparing, suppose SSD, or tomorrow at 5 p.m. you are taking the same channel FM.
Right.
And he is literally preparing, he will be doing PYQ.
Correct.
At least 1 or 2 test series. Then that question in PYQ of SSD or fluid mechanics, it will be so much time, the question will be flown in front of his eyes, that if he wants not to remember SSD formula, it will be remembered. Same like bending stress here. Right. If generally anybody has prepared, so many times he has done the PYQ, so many times the bending stress will be coming or SSD will be coming, automatically it will be remembered. There is nothing special to remember it if they are genuinely preparing.
Right.
Now let me ask you one thing. Okay, and guys, you can ask also whatever you want to ask from your favorite ninja sir. Sir, I would just want to ask you that when you have gone for the exam, many students will not complete 100%. Even rank 1 also 100%. Might be all subjects you will be doing, not 100% topics. How much percentage you have covered when you given the exam?
Sir, actually, when I gave the exam, I completed 100%.
Okay.
So, because I was dedicatedly preparing for that particular exam only, I wasn't like, I made a mistake. In my final year when I tried to be Ajay Devgan. So I was trying to, stand on 2 different bikes like this. So on my one leg was in SSB preparation for Indian Army, and my other leg was for preparing this GATE examination. And that went terribly wrong, and I did not even clear the SSB, and I did not get the good marks in GATE as well. But next year I made sure that I'm not repeating the same mistake, and that is the only thing that we want from you also. If you're making mistake, that is perfectly fine, just don't repeat, okay? That is more important. All formula class is there, but if possible, please arrange class for all subjects. Yes, Diksha, it is already going to happen in Hindi channel, you all know, right? Last year also we did the same thing. We took the session in which we have discussed the formula of each and every subject, right, in one session only. So it is my kind request, if you haven't subscribed to the channel, you can go and subscribe the channel, and also you will get the notification whenever the session will be happening, right?
Okay, first MSQ will be done. After that Formula 1 will be done. For first half of January, I guess around 12th of January this will be done. I have shared in my Telegram the complete schedule of MSQ, Civil by Abhinav sir, or will share in Civil by Ninja sir as well. Okay, go to that Telegram channel, we'll be sharing it. I have already shared, sir will also share. And after MSQ will finish I think around 12th or 14th of January, then Formula 1 series for every subject will be there. So please, what happens we are doing many things, but many students are not subscribing to the channel, either English or Hindi. So once I told you this, that Formula 1 is there in the Hindi channel, they will be, oh yes, that will be fine. But after, see, it will be after 12 days or 13 days. So after that time, they will forget it. So please, that is the way, that's why we say to subscribe, so that nothing important is missed. Okay, so I don't, if you love the channel, either this one or Hindi one, subscribe it as it is. If you don't like it, then why to waste time on that? Okay, so please, and guys, today 9 p.m. is the session, and from tomorrow MSQ series is on the way for civil branch and for everybody branch there. Especially MSQ question design, because you will never find MSQ question in any book, because no book has been made till now.
Right, right. And those who are saying MSQ should be in English, so don't worry. You can also watch the session, because all the technical terms and everything will remain in the English only. We have never used Hindi while we are teaching anything, because we also don't, I'm like, specifically, I don't know how to speak in Hindi all these words, technical words. We also speak in English only, right?
So what is this?
Sir, this is sanitizer,
But
sir.
it's different color, na? See how sir sanitizer is looking.
Yeah, that's
Totally
how
different.
ninjas.
It is just
Special.
looking like something like S2SO4 or something. But it is looking very dangerous.
Ninja special. Acha, there's two things which I would like to acknowledge, and please guys, send me a heart sign if you are having the same trouble. First is related to the short notes. If you are having issue related to short notes, please send the heart sign. Any doubt related to short notes, because we'll acknowledge the whole thing. And the second thing is about getting less marks in the test series, and that is going to affect you, and it is already affecting you by demotivating you. So if these two issues you are facing, please send us a heart sign, and accordingly we are going to reply to you. Please everybody, full power. Maybe I am doing same mistake. Ajay Devgan, 31st Jan, MHADA, Maharashtra, then GATE, then ESC. Arey bhai. At least you are having, bikes both side. I had horse one side and another bike other side. So see, one thing I can say about, sir, short notes बनाए थे आपने?
Sir, I
Ever prepared? Never?
no.
Never. I haven't prepared it. But yes, there was the dilemma. There was a dilemma in my mind all the time that I should have made them, I should have made them, I should have made them, I should have made them. But today I can say, if you haven't made the short notes, it is perfectly fine. And if you are having your short notes, then also it is perfectly fine. Just make your brain confusion less, dilemma less. That is the only thing important right now, to make your brain super clear, right? So if you haven't made the short notes yet, perfectly fine, no problem, because it is not at all important. Those who are going to make the short notes, they are only going to get the selection, or those who are not making the short notes, they are only going to get a selection. Whatever suits you, you have to do that, okay? And coming to the question that you are getting demotivated because you are getting less marks in the test series. So what are you what is your expectation? You should get 100 out of 100? You should get 90 or 80? No, right? Why you all are giving test series? You are giving test series because you want to see what are the potential mistakes that you can make in the GATE examination on 12th of February. So you have to make all those mistakes in the test series itself, right? Don't look at the marks, look at the mistakes that you are making. That is more important, and do not repeat those mistakes. If you are like me, you forget about those mistakes, note them down, and please recall them whenever you are going to give the test series. That is very important.
Okay, I think guys, that's it for today. Okay, and let me show you the session. Okay, questions I'm giving you assignment. Guys, see, today 9 p.m. Okay, today 9 p.m. guys, the whole mystery of MSQ will be revealed. Okay, 9 p.m. Hindi YouTube channel. Please subscribe that. And you can join me in Telegram, Civil by Abhinav sir. I'm just after completing session, within 2 to 2.5 minutes, I'll be sharing this whole PDF with you. Of first 4 chapters: bending stress, shear stress, SFT, BMD, and stress strain. And yes, guys, this is today's session on the same channel. 5 p.m. Ninja sir will be telling you fluid mechanics part 1. Okay, today is SOM 1 FM1 and tomorrow is SOM 2 FM2 along with the mentee session. Today is SOM 1 FM1. Half of the SOM I have taught. Then now sir will be teaching you at 5 p.m. Please share that session. Please share.
Tomorrow also will be following the same schedule for the same subject.
Okay. So just
Right.
let me share you the link, guys. Everybody, please.
Sir is giving you the link, and tomorrow also the same schedule will be followed. Abhinav sir will be same time. Abhinav sir will be taking the part 2 of this subject, so at 10:30, and I'll be taking fluid mechanics at 5 p.m. But tomorrow there is something else also for you all, and that is the Minty War. So tomorrow there is going to be two teams, the Ninja team and the Commando team, and we will see who is gonna win this game. Anyways,
Guys, this is
Commando
Joshi
team is
sir's
in lead.
link of 5 p.m. today, and I have liked it just now. You also please like and share. This is the Joshi sir. Both links are same. Just any one of them, go and please like it. 5 p.m.
Right.
today.
All right. Curious to know, so today we are fluid dynamics. For your gate point of view for fluid mechanics. Okay? So any other doubts if you are having, you can ask us. We'll be available for you in every manner. Telegram, Facebook, wherever you want, wherever you find like we are more easily reachable to you. Please reach us, and literally asking come to us if any difficulty, state examination, you can, okay, you can, जो भी doubts हो please पूछो उसको. Do not feel like you are alone, do not feel like you don't know how to deal with your problems. If you feel like that, we are available for you all the time. As you can see, you have our email ID, you have everything. This is the era of internet. You don't have to write letter to us, right? Full power पूछो जो पूछना है बिंदास. We are always here for you. Audio problem? Hello? गया क्या sir?
Okay.
Oh no.
Okay, guys, I think it's now fine. Okay. Let us. Okay, guys, so see you at 5 p.m. Sir will be there in the same channel. 9 p.m. I will be available in Hindi channel. Thank you, guys. Take care. Stay safe. Stop streaming.